Hello everyone, welcome back to my channel. This is the second part of the introductory video of ANSYS, and this video contains the basic thing that is needed for a beginner to start this simulation software. So if you find this video useful, please subscribe to the channel. Okay, now when we will double click the ANSYS workbench icon on the desktop, a window like this will appear. It will be an unsaved project of workbench. In the first thing is that you have to set the view as default so that your toolbox, project schematic and system coordinates, these things should be visible to you. Now the first thing is the analysis system. These are the different modules that are used for the different types of analysis. For example, the most common or most used mechanical module is static structural. This module is used for the basic structural analysis such as stress strain, which are at a static position, which is not moving and which is not varying with time. We use static structural. Then it is the steady state thermal. Non-time variant thermal analysis is done in the steady state thermal. Then the transient structural, the name suggests, for the transient structural analysis this module is used. The modal analysis and the harmonic analysis harmonic response, these are used for the vibrational analysis. Then comes the fluid flow fluent. This is the module that I use for the computational fluid dynamics. You can see the videos present in my channel. These deal with the fluid flow fluent. It is a great software. So like this, you have all the modules present here for which you can work. Some electrical analysis can be also done using this software, so the modules are present here. Then if you want to start a basic analysis, for example say a structural analysis, just click it and drag it to the project schematic and see the window here. It is a bit slow right now. Yeah, one more thing, you can check the units from here, the unit that you want to be present. Okay, let it be. Then here is the engineering data. Engineering data is a warehouse of all the data values that of materials that are most common, which a person can use. Go to engineering data sources. From here you can see different types of material that people use in their analysis, but it is not a constraint. If you want to use some new material, you can definitely use it by adding that material. You have an option of that. You can click here and add a new material. Okay, here for example, if you have to choose air, then you can add this structural steel, water liquid. These all are common, so they are in favorite. Otherwise you have to go to that particular section. And in the bottom you can see the thermal and the different properties of that material. For example, granite, you have all the properties listed here, that is of that particular material. So we have added some material here. Now we can go back to the project. Just now in this 19.1 there is a feature called geometry. In geometry you can make geometry in two types of software. First is space claim, and the second is design modular. Since in the previous versions only design modular is present, so I am comfortable with design modular. You just have to right click and click on design modular. It will open a new window that will contain the toolbox to make the geometry. You can import different geometry from different other softwares like SolidWorks, CATIA, but if the geometry is quite simple, you should make it in the ANSYS itself, as it will be better for the analysis. You can have a good control over it if it is made in ANSYS itself. Units is take it as millimeter. This is I will show a very basic example to use this software. So I will for example say take a specimen, cylindrical specimen. For that I will use a circle with a particular diameter d1. The diameter say 15 mm. Okay, now go to modeling and extrude it. Add material and its length, put the length as 80 mm and generate it. This is a specimen of we have not used the material yet. We will add the material later on. This is just the geometry of that specimen on which we are going to have the test. Okay, now you can name it, but I will leave it right now. Close the window, open the model and go to edit. It takes a few seconds to start and depends on your computer or configuration also, so you have to bear it. Now the geometry is imported in the model completely. Now from the start we will see what is done. In the geometry section, click on the solid. This is the one body that is present. The assignment here is steel. We have added few more elements to it, but I will keep it as structural steel. Now we have these materials that we have added earlier in the engineering data. Now the very important thing is mesh. Meshing is a very important parameter which determines the quality of result that you get. It creates the mesh tool creates a mesh of polygon or quadrilaterals, triangles, in order to increase the accuracy of the result or the simulation in a finite element analysis. Now in the mesh there are different things that are present. The first thing is the sizing, the element size. The element size, in this you can define the particular size which you want. For example, I took it as 0.002 meter, that is 2 mm. Then the sizing option is present there. In the span angle center, if you want to get a very fine result or very good result, you should use the fine option. It is a very complex process. I have a video on the meshing of in ANSYS, so I will not go very deep in this introduction video. If you want more information about it, you can see that video, or I will in future, maybe I will be uploading more videos on meshing, as this is a very important topic. Then you can check the quality here. You can add different methods to make the meshing more fine. For example, currently I will generate the mesh. You can see here in the statics the number of nodes is 17,866. It is okay, because in the academic section you cannot cross the number of nodes more than 32k. Now if in the mesh, if we add inflation, and in the boundary we will add the geometry of and then create the mesh. Now we can see the difference here. In the diameters, near the diameter end, there will be a lining, different type of lining present, just because of the inflation that I have introduced. Likewise, there are many different things that we can introduce, which you can learn in separately. Now we will go in the static structural zone. There is a question mark because till now the question has not been defined yet. So we have to apply some load on it. For example, if I apply the pressure or force apply, we have to select the geometry. On one face we will apply load, say 50 Newton, and direction is outward, but we can change it. Apply. But we have applied the force, but we have not given any support, so we have to give a support to it, fixed support. So now it is one side is fixed and one side is applied a force. So now here you can see the question mark is not present here because the load is defined here. Now we have to see the results. We can see the results here, different. In the fatigue tool we can see the factor of safety, so that will it survive the load or not. Now we will click on solve. It may take a while to get the results. This is just an example to show how to use the software. You can do whatever you want to do using this software. Using these options, you can choose your own experiment. This is just a way how you can use it. And one more thing, this mesh is not very good. I have just shown you how to do the meshing, but this mesh is not so good, so don't take it as a good example of meshing. This is not a good example of meshing. Now you can see the result here. The force is applied here, so the maximum deformation is shown here. You can see the animation. The factor of safety is 15, so that means that this can stand that force. It is good, and life is 10 to the power 6. In the energy probe, it is seen that the strain value is 2.815 into 10 to the power minus 6 joule. Now, as we have seen how we can see this is just an example of how we can do the simulation. Start it. In the results you can see the same results which was present in that model. Here I want to show you the energy probe. The energy probe has calculated the inner strain value here. Now if you change the force value from 5 to say 500 and solve it, for a value. Now for the same specimen, if I change the magnitude to 20 kN and solve it, I will get another result. the factor of safety here drops to minimum of 0.6. That means a particular section of that specimen will fail because of the force applied to it. So this is not a good design for that particular amount of force. Here this by this way we can check different values for different body. This was just an example to show you how we can work on this software. These are different options to view the results. Okay, now we will close that. Now one more thing I want to say, that if you want to add some more modules or connect this static structure to another, for example model, just click on it and drag it and share it to the model. Now what will happen, the data from this static structure will be shared with the model module, and you can do the analysis likewise here. And if you want to do the component of the module separately, you can use the modules from here. For example, geometry as separate, you can use it as separately and then link to other modules. Mesh is different, you can do it likewise. So I think this basic understanding of ANSYS will give you an idea on how to start the project and how to go through it. And you can watch the videos present in my channel that will help you to move forward in your project. So if you find this video useful, please subscribe to the channel, as it will make me more and more desperate to make more videos and make you share the knowledge with you all people. So if please like and subscribe to the channel, and if you have any queries regarding the mechanical project, please email it to my business email ID that is present in the about section of the channel. Thank you very much.